I still don't know how to do it. Yeah. All right. You should be wearing a real mask. That'd be better. Oh, yeah.
Okay, so how's it going? Better. Good night's sleep. Aren't you glad that the labs are due at midnight instead of 4 a.m.? So we don't have a whole lot of time today because they're doing course evaluations. That'll start in 15 minutes. So today's Q&A day, and I'll give you a couple comments on what I've been seeing when I've been grading exams. Because there's a few things that I've found that are generally misunderstood. First off, okay, so if I give you a function that looks like this, and I tell you to draw a stack frame, what information do you need to know? If I say right after this printf returns, what's the stack frame? Do you need to know, what do you need to know? For optimizations turned on, global variables, local variables, what else? You see the pass parameters. Is this a process? Do you need to know that? Depends on how much of the stack I want you to draw. That's probably a good way to say it. But if I just say, okay, restrict your stack frame to just this, does the fact that you call this as a function versus if you swap it in using context switch change the stack frame? No. It does not. Okay, well, all right. It'll change it in one slot. The link register. When you swap a process in with our standard context switch, the link register doesn't contain something explicit. We don't ever write to LR when you first swap in a process. And we talked about that when I talked about the solutions to the exam. What dictates this guy's stack frame is what code the compiler emits for this set of C code. So when you're drawing a stack frame over here, well, at least we got a good loud knock. So when you're drawing a stack frame, where are the high addresses, where are the low addresses? Okay, all y'all know that. Why didn't you write it down? No. Yeah, you're saying, I know, that's good. Okay, like that, high and low? Okay. So, do we start drawing stuff with the low addresses going towards the high, or the high addresses going towards the low? High addresses going to low. What should be at the bottom of your stack frame? What? Return address? How many of y'all vote return address? Yeah, you vote for it. Okay, Steven's voting for it. Thank you for taking a stand. Pass parameters? You're thinking x86.
What do you mean by the bottom?
So what I'm saying is if this is all that I give you, and I just say, here's a function, draw the stack frame for that function, that's all the scope that you have. All you know is that there might be other stuff down there, but you don't know what it is because you don't know who called this function. So the only thing that gets put on here is what this function put on the stack. So what's this function going to put on the stack? Do you know what it's going to put on the stack? When did I make you learn what it's going to put on the stack? Lab 5. Remember this? I made you go and figure out what the calling convention for the ARM processor is. You remember the STMFD, what is it, the FPIPLRPC that it puts on there the very first time? So it's going to push on there, if optimizations are not turned on, it'll put on there FPIPLR and PC. In what order? PC's last or PC's last? Last. Why is PC last? I'm pushing all four at the same time with an STMFD. The highest numbered register goes at the highest address. Okay. PCLR IPFP. Okay. That tells me register names. That doesn't tell me anything else. What is LR? Is it actually physically taking the latch that holds the 8 bits and putting that into memory? I mean, the register is a physical thing. This is actually what we're referring to. This is shorthand for saying the contents of the LR register. But if I want to know what you understand about this, you got to tell me what LR is. This is the return address that tells me what address should I jump back to when test P is done. How about IP? It is not garbage. We know something very specific about what it is. Because there is an instruction that happens right before the STMFD, which is move SP into IP. So this is a pointer to the stack. So I know exactly where this is. Where does IP point? Okay. IP is a pointer. Does it point to PC, or does it point below PC, or at the little line in between PC and what comes below it? And what does that mean? When you're doing this on exams, I won't nitpick exactly where you put the line unless it's significant and I want you to be able to distinguish to me. And I'll make it clear on an exam whether or not I want you to distinguish. And if I intend to make it clear, but I don't actually make it clear, and everybody is smorgasbord answer, I won't take points off. But I want you to understand. The most important thing is not the point. The point is, do you understand what this means when we draw an arrow from IP over to PC? What we're saying is this slot, this 4-byte slot on a stack, contains an address. The address is the address at which PC is written. Okay, PC takes up 4 bytes. And because we are a byte addressable machine, it takes up 4 addresses. Which of the 4 addresses is it? The lowest. Little Indian machine. So, and actually it has nothing to do with the Indianness. It's just the lowest address is the address that where, if you have a pointer to a multi-byte word, that pointer contains the address of the lowest of the 4 addresses. And that address had better be in a multiple of 4. That has to be aligned. Okay? So technically, if you're actually drawing little lines on this stack that indicate byte boundaries, instead of just treating this whole thing as a 4-byte chunk, the arrow actually goes kind of up towards the top of PC because that's towards lowest addresses. So if you ever said, I want to fetch whatever IP points to, you'll fetch all 4 bytes of PC, but the address that it contains is the first byte of PC, or the lowest address of the memory location holding the PC. Okay? Does that make sense? All right. What can you tell me about FP? Where does FP point? If I'm using a frame pointer, where does the frame pointer point? So what you do is you save your old frame pointer and you create your new frame pointer by moving, after you've saved your old frame pointer, the stack pointer into the frame pointer. Okay? So I'm going to point the frame pointer register somewhere in here. But I saved my old frame pointer. So this guy is a frame pointer to whoever called me, their frame. Where's their frame? Below. Downstairs one slot. So we know that this guy, FP, is a pointer down a bit. So somewhere down there. We don't know where, we just know it points down there somewhere. Caller's frame pointer. What else is going to be on this stack? All right, so here's the question. Will it push all the registers, R0 through R10? And then will it push CPSR, and then will it push a pointer to self? Why not? Don't we need to save all the registers? Okay. Which registers are call E-save and which ones are call R-save? R0, R1, R2, R3 are caller save. Are we, when we're talking about the initial stack frame, when we first start executing this guy, are we the caller or the callee? We got called. We are not calling anybody till we get down to printf. Okay? So we're the callee. So do we need to save immediately all the callee save registers? How paranoid are you? If you're the compiler, you try not to be paranoid, because paranoia means you spend a lot of time saving stuff you don't need to save. So what we're going to do is we're going to figure out which registers of the call eSave registers are we going to actually use. And we're only going to save those. If we're not going to whack them, why save them? So the compiler will go through and look and see how it's compiling all this code, and if it's not going to whack R10, why save R10? Okay? So you don't have R1, R2, R3, R4, R5, R6, R7, R8, R9, R10 all pushed onto the stack on your stack frame, regardless of whether you came from context switch or not. That doesn't happen. If you use all the call eSave registers in here, in your code, if the compiler allocates all those registers, then yeah, you'll save them first. But in general terms, you don't save them first. Okay. Is there any register that we absolutely know that we would have to save right off the bat? What are we going to do down here? We're going to call printf. What will a call to printf whack? Going to whack the link register. We're going to pass parameters, 2 parameters here. The first parameter is the format string, so we're going to pass the address of the format string in the first parameter. We're going to pass a copy of P in the second parameter. So we know that we're going to whack R0 and R1 here. Those are caller save registers. Are they whackable? I can whack them without worrying about it, right? Okay, so do I need to save R0 and R1 before I whack them with a call to printf? How many of y'all vote no? How many of y'all vote yes? Anybody who's saying you do need to save them, tell me why. Test P is now a caller. Okay. So, therefore, if there is some value that's going to be in one of those 2 registers that I want to be preserved across the function call, I've got to save it and then restore it. Is there anything that's going to be in those 2 registers, R0 and R1, that I want to preserve across the function call? Not a maybe, it's an absolutely. What's in R0 when you start this function? P. If you whack it, where do you get your P the next iteration of the loop? So you have to save P. Okay? Tony.
So if you're going to pass it to printf, that's the only time you need it. Couldn't you just move it into R1 because that's where printf is going to get it, and then just leave it there? You wouldn't have to push it.
Okay, so the question is, well, why don't we just move R0 into R1 in preparation for the call to printf, and then move R1 back into R0? And just kind of keep track of it that way.
Well, you wouldn't even have to move it back.
Or if we just initially move R0 into R1 and always reference our parameter by R1?
Yeah.
It's okay. the issue is that R1 is a call or save register. So we assume that when we call printf, which we know that printf does a whole lot of shenanigans, we assume it will whack R1. We have the convention to where we have R0 and R1 contain values, we send it to printf, and that's the convention whereby we communicate information to it. But printf doesn't have to keep that information in those registers because those are call or save registers. It can whack them. So we have to preserve them. The only way that it'll work is if we moved the contents of P into one of the call-E save registers. But because we're the call-E, we got to save those before we use the call-E save register. So we might as well just push it onto the stack to begin with. Okay? This holds whether or not you're a process, whether or not you're swapped in with CS, or whether or not you're just called as a regular old function. This calling convention holds regardless of whether you're preemptive, cooperative, or anything. Okay? Questions about this? A lot of other common problems that I would like to take the time to point out and iron out, but I got to go, and I forgot the paper. Okay. Questions? We are not having class on Monday. I will be available to answer questions, whether physically or virtually.
Okay.
How's that for a non-committal response? The other thing that we wanted to say is this course evaluation is a new course evaluation. You're getting two of them. You're getting the standard one and the new one. I want you to take them both seriously. We want good feedback from the class. I mean, if you can cook up anything that we can do to make your lives less of a huge old pain, please let me know, okay? I'm all ears. I'm very interested in hearing what you guys have to say. The new one has like 40 questions on it. I'm sorry. Just please try to keep the brain engaged while you take it.
Okay. Yeah, you guys are supposed to be big guinea pigs. This is the new form. You just need to fill in all the circles. Don't write comments.